look at section 1.6, problems 33 through 35 in this video. Okay, so let's start with number 33. Number 33 starts off with asking for the domain of f. Okay, remember the domain is the x value, so let's highlight the function f in blue. Okay, so there's f. The domain would be the x value, so if you take a look, what's the smallest x value? Remember, this is our x-axis right here. If I look at the smallest x value, that would be right here. That's the one furthest to the left, which is 2. And the number furthest to the right would be right here, which is 11. Okay, so that's the domain of f. Now let's look at the domain of g. Okay, the domain of g, let's highlight g in green. Okay, so again, we look at the smallest x value. The smallest x value would be right here, which is 1. And then the highest value would be right here, which is 9. Okay, so that's the domain of f, and that's the domain of g. Now let's go on to the domain of f plus g. The domain of f plus g, f minus g, and f times g are the intersection of the domains of f and g. So what I want to do is I want to look at the intersection of these two. I want to see what they both have in common. What x values do they have in common, in other words? And then we'll answer 33 and also part of 34. These will all have the same answer. Okay. So let's look at the graph here and think of the smallest x value, which would be included in the intersection, and the highest value that would be included in the intersection. It's what they both have in common. So if I take a look at these, if I think of what's the smallest value that would be included, 2 would be the first number that's included in both of them. So again, if you look at the x value, the smallest value would be 2 because that's included in both of them. And the highest number would have to actually include both 11 and 9, so I would actually pick 9. Or if you look at your picture right here, you'd pick 9. Okay, so that would answer these 3 questions. Okay, now let's go to the last part of number 34. It says find the domain of f divided by g. Okay, the domain of f divided by g would be the intersection of f and g, of the domains of f and g, but we would have to exclude all values of x that make g of x equal to 0. Okay, so let's go ahead and go back and look at g of x here. Okay. G of x is a green one, so let's go back here. Okay, so here's g of x right here. You could tell that it's never going to be equal to 0, which would be along this line right here. So there's nothing to be excluded. So the domain would be the same as all the examples above here. It'd be 2 to 9, including the 2. Okay, now let's go on to number 35. This one's a little bit different. It's asking for the domain of g divided by f. So what I'm going to do is I'm going to look at the intersection of the domain of f and the domain of g and exclude any values of x that make f of x equal 0. Okay, so let's go back and look at f of x. That's the blue curve here. Here's f of x again. It's equal to 0 right here as I circle, which is 3. Oops, I just wrote that incorrectly. Let me correct that there. Okay, when x is 3, f of x is equal to 0. So I have to exclude 3. So I'm going to look at the intersection of the domain of f, the domain of g, which would be all these answers right here. But I have to exclude 3. So I'm going to go from 2, including 2, to 3, not including 3, union, which means the word or, 3 to 9. Okay, so that takes up to number 35. Number 36 and number 37 will be on the next video.